On a seemingly ordinary Saturday morning, the ground shook across a large swath of the southeastern United States. The day began like any other, with residents going about their usual routines, unaware of the geological event about to unfold beneath their feet. At precisely 9:04 a.m. Eastern Time on May 10, 2025, a magnitude 4.1 earthquake struck near Greenback, Tennessee. The sudden jolt caught many off guard, as the region is not typically known for such seismic activity. This small town, located approximately 30 miles south of Knoxville, became the epicenter of seismic activity that rippled across state lines. The tremors were felt as far away as Georgia and North Carolina, causing a momentary pause in the daily lives of thousands. The quake, originating about 15 miles beneath the surface, served as a stark reminder that even seemingly stable ground can shift without warning. The seismic waves traveled quickly, shaking buildings and rattling nerves. While not typically associated with frequent seismic events, the region falls within a known active seismic zone. The New Madrid seismic zone, which extends into parts of Tennessee, has a history of producing significant earthquakes. This unexpected tremor became a topic of conversation across the Southeast, as residents from various states shared their experiences of the brief but noticeable shaking. Social media platforms were flooded with posts and videos, capturing the immediate reactions of those who felt the quake. The earthquake, though moderate in magnitude, served as a reminder of the Earth's inherent dynamism. It highlighted the fact that our planet is constantly changing, with forces beneath the surface that can alter our environment in an instant. It highlighted the importance of understanding seismic activity and prompted discussions about preparedness, even in regions not traditionally considered earthquake-prone. Families revisited their emergency plans, and schools conducted earthquake drills to ensure readiness for future events. As scientists and officials assessed the aftermath, the event underscored the need for continued research and public awareness regarding earthquake hazards. The data collected from this earthquake will contribute to a better understanding of the region's seismic activity and help improve safety measures for the future. While the epicenter lay near Greenback, Tennessee, the earthquake's effects were felt far beyond the immediate vicinity. The seismic waves traveled through the Earth's crust, reaching numerous states across the southeast. Reports of shaking poured in from a surprisingly large area, demonstrating the wide-ranging impact of even a moderate earthquake. Residents of Tennessee, Georgia, North Carolina, South Carolina, Alabama, Kentucky, and Virginia all experienced the tremors to varying degrees. Major cities like Chattanooga, Tennessee, Atlanta, Georgia, Asheville, North Carolina, Greenville, South Carolina, and Macon, Georgia, were among the urban centers where the shaking was distinctly noticeable. The widespread reach of the earthquake's tremors underscores the interconnectedness of geological processes. It highlights how energy released at one point can propagate through the Earth's crust, impacting regions far removed from the source. As the ground shook across the southeast, people immediately took to various platforms to share their experiences and seek information. The tremors were felt in multiple states, causing a wave of reactions that spread rapidly through social media. People were eager to understand what was happening and to connect with others who were experiencing the same unsettling phenomenon. Social media sites lit up with posts describing the shaking, ranging from mild vibrations to more pronounced jolts. Hashtags related to the earthquake quickly began trending, and users shared videos, photos, and personal accounts of their experiences. The digital landscape became a real-time repository of the event, capturing the immediate aftermath and the collective response of the community. The unexpected event quickly became a shared experience, connecting people across state lines through their common encounter with the earthquake. Neighbors gathered outside, discussing the tremors and checking on each other's safety. Online, people found solace in the shared experience as they exchanged stories and reassured one another. This sense of community, both physical and virtual, highlighted the human need for connection in times of uncertainty. The United States Geological Survey, responsible for monitoring earthquake activity, received a deluge of reports following the event. Their systems were inundated with data from individuals eager to contribute their observations. This influx of information was crucial for scientists to accurately assess the earthquake's impact and to provide timely updates to the public. Within the first hour alone, over 30,000 reports flooded in from individuals who had felt the tremors. These reports came from a wide range of locations, painting a comprehensive picture of the earthquake's reach. The sheer volume of submissions underscored the widespread nature of the event and the public's proactive response. This number continued to climb, eventually exceeding 40,000 as more people shared their observations with the agency. Each report added a valuable piece of data, helping to refine the understanding of the earthquake's characteristics. The collective effort of thousands of individuals provided a detailed and nuanced view of the seismic activity. The large volume of reports submitted to the USGS reflects the public's heightened awareness and desire to contribute to scientific understanding. People were not just passive observers. They actively engaged in the process of data collection, demonstrating a keen interest in the science behind the tremors. This engagement was a testament to the power of citizen science. Citizen science, in this case, played a crucial role in helping seismologists map the extent of the earthquake's impact and refine their models of seismic activity in the region. The collaboration between the public and scientists not only enhanced the accuracy of the data, but also fostered a sense of shared purpose. This partnership exemplified how collective efforts can lead to a deeper understanding of natural phenomena and better preparedness for future events. Despite the widespread shaking felt across the southeast, initial assessments indicated minimal damage from the earthquake. The tremors were felt in various states, causing concern among residents, but the overall impact was less severe than initially feared. Emergency response teams in affected areas, including the Knoxville Fire Department and Knoxville Police Department, reported no significant structural damage or injuries. These teams were quick to mobilize, ensuring that any potential hazards were promptly addressed. Their swift action helped to reassure the public and maintain order during the aftermath. As a precautionary measure, the Great Smoky Mountains National Park temporarily closed the Foothills Parkway West for a thorough inspection to ensure the safety of visitors. Park rangers conducted detailed assessments of the roads and surrounding areas, looking for any signs of instability or damage that could pose a risk to travelers. Similarly, the Tennessee Valley Authority conducted precautionary inspections of their dams in the region, including Fontana Dam, Fort Loudoun, and Tellico dams. These inspections are crucial for maintaining the integrity of the dams, which are vital for flood control, water supply, and electricity generation. The inspections revealed no damage to these critical infrastructure components. The TVA's proactive approach ensured that any potential issues were identified and addressed before they could escalate. The absence of significant damage from the earthquake can be attributed to several factors, including the moderate magnitude of the event and the relatively deep origin of the seismic waves. The depth of the earthquake helped to dissipate the energy before it reached the surface, reducing the potential for damage. Additionally, building codes in earthquake-prone areas often incorporate seismic design considerations to enhance structural resilience against ground shaking. These codes require buildings to be constructed with materials and techniques that can withstand seismic forces, thereby protecting lives and property. Throughout history, this region has experienced numerous earthquakes, each one shaping the landscape and the lives of those who inhabit it. From ancient times to the modern era, the ground beneath has never truly been still. Records show that significant seismic events have occurred roughly every 50 to 100 years, reminding us of the Earth's restless nature. It's fascinating yet humbling to think about how these natural forces have continuously molded the world we live in. The patterns and frequencies of these earthquakes provide crucial data for scientists, helping them to predict future activity and prepare for the inevitable. Understanding this history is key to mitigating the impact of future quakes, ensuring that communities are better equipped to handle the challenges they bring. Over the centuries, this region has experienced numerous earthquakes. Each event has left its mark, shaping the landscape and the lives of those who call this place home. From minor tremors to major quakes, the history of seismic activity here is both rich and complex. Aftershocks are a common occurrence following a major earthquake. These smaller quakes can continue for days, weeks, or even months. They serve as a reminder that the ground beneath us is still settling. But what about future risks? Scientists are constantly studying patterns and data to better predict when and where the next earthquake might strike. While it's impossible to predict with absolute certainty, ongoing research helps us prepare and mitigate potential damage. You might be wondering, why did the shaking travel so far? The answer lies in the nature of seismic waves. In the eastern regions, the Earth's crust is older and more rigid, allowing seismic waves to travel greater distances without losing much energy. This is why an earthquake in one area can be felt hundreds of miles away. Understanding these waves helps us better grasp the impact of earthquakes across different terrains. Making sense of the shaking involves piecing together data from seismographs, eyewitness reports, and geological surveys. Each piece of information helps build a clearer picture of what happened and why. By studying these details, scientists can improve building codes, emergency response plans, and public awareness, ultimately making our communities safer and more resilient in the face of future earthquakes.